Assalamualaikum warahmatullahi wabarakatuh. Very good morning to everyone.
Salam, Doctor.
So before we start the session, maybe I would like to check the presenters. Do we have all the presenters here?
Not
yet, right?
Yes.
Alright, okay, never mind. Let's wait for them because the keynote speaker is still presenting.
Yeah.
So at the same time, I also need to evaluate. We only have 2 presenters, kan?
Yes, we have only 2 presenters and 2 invited speaker. Doctor already get the evaluation form, right?
Information of?
Evaluation
Oh yeah, I
form.
already have it.
Alright, okay, Doctor.
And already open it. Alright. So later on, how will you inform me about the best speaker? Are you going to WhatsApp me?
Yes. It's either me or the moderator. I will WhatsApp you.
Oh, okay. Because sometimes, during this thing, I will not see my WhatsApp.
Oh, okay.
Let's check. Boleh tak? Hopefully boleh nampak. So 3 of us only. So temperature. Alright, so we do have the presenter. Assalamualaikum. So let me just check. Okay, we have Mrs. Afrin. We are still waiting for, do we have Mr. Abdul Rahman here?
He's not here yet.
Not here yet.
Them.
So, okay. So we just have three of us. Do we have Mr. Abdul Rahman now?
Mr. Abdurrahman will be presenting online. Sorry, pre-recorded. So
Okay.
he will only for question answer.
Or Q&A. So I think we can start the session now. So I would like to have the IT committee to play the pre-recorded video of Mr. Abdul Rahman.
Yeah, but I think we need to wait for the evaluator first.
Oh, all
Yeah.
right. Yeah.
Dr. Malinda and also
Yeah.
Dr.
Dr. Malinda is chair in the keynote session. So
Oh,
just
okay,
wait
no
for
wonder.
them. Yeah.
Right.
Assalamualaikum, doctor. How are you?
Good.
This is Dr.
Alhamdulillah. How are
Zaira.
you? Yeah.
Alhamdulillah, I'm okay. By the grace of Allah, I'm okay. Your university is closed, right? Can you go there? No, right?
Just can go for a while lah, but without the technicians, it's very difficult to do activities there. If anything happen,
They will.
yeah,
They are very strict.
yeah. And my
They are very.
students, they stay outside the campus. So if I request them to come to the campus, and now the campus also has these COVID-19 cases, I also feel afraid I might cause the problem to my students.
Sorry,
Yeah,
Dr. For
Yeah.
interruption. Mr. Abdurrahman, can you please ask for sharing audio and video?
Okay, let me just do the microphone checking and reminder. So, Assalamualaikum warahmatullahi wabarakatuh and a very good morning to all. So, ladies and gentlemen, we are about to begin soon. So, please stand by. I would like to seek your kind cooperation to avoid any visual disturbance during the live broadcast session. If you have any questions, the conference resource personnel are ready to attend you at the reception desk. So thank you for your kind cooperation and attention. I think we will start probably at about 5 minutes, okay, after Dr. Marlinda already being here. So we will have two speakers to be evaluated for this session. Right, we have Mr. Abdurrahman bin Abdurrahim and Mrs. Afrin Jahan. And after that, we will have invited speakers, Dr. Adiola Akin Pelu, and also Dr. Zaira Zaman Chaudhry. So may I know the presence of the invited speaker? We have Dr. Zaira here. How about Dr. Adiola? Yeah.
Sending him message. He's from Saudi Arabia. Actually, 5 hours back from us.
Yeah, if
And
you
he
already
has-
here, please just click the join button so that we will know your presence.
I'm not actually Adiola is present or not. I'm not sure, but I am sending him message.
Okay. So I also cannot see now the how to check everyone.
Okay,
Okay, we have many participants now.
Good morning, Dr.
Okay, so and hi, good morning, Dr. Boon.
Hi, Dr. Rika. Dr. Malinda is still at the main hall right now, so we'll wait for
Yeah,
him. Okay.
I think we have to wait for her.
Yep.
So we are still waiting for Dr. Marlinda, the evaluator, Mr. Abdurrahman. Okay, the speaker. and Dr. Adiola, the invited speaker. How to check participants?
People.
Because I minimize this thing so I cannot see. All right. So can click here. Session. People. Oh, this one. Yeah. Frame. Wonderful of us. Daniel Saida is here. Okay, Abdurrahman is already here. So another one. Okay, we are still waiting for. Okay, since we have Mr. Abdurrahman here, we are just waiting for Dr. Marlinda. So
Close, so she will be soon here maybe.
yeah. Can we have the? Okay, never mind. Probably I will just start, and the IT committee maybe after that can just show the presentations of Mr. Abdurrahman. So, Assalamualaikum warahmatullahi wabarakatuh, and a very good morning to everyone. Now we are in the parallel session 4 under biofuels, biomass, and biodiesel topic. So now our first presenter will be Mr. Abdurrahman bin Abdurrahim with the topic removal of heavy metal by emulsion liquid membrane. So probably we can see Mr. Abdurrahman. Even though you are going to use the pre-recorded, can you show your video?
The video. Can play now? Are we started now?
No, we just want to,
Okay.
yeah, have something to talk first before we have Dr. Marlinda entering this session. Because Dr. Marlinda is going to be the evaluator, so I believe she need to be here before the first speaker start. But can we see Mr. Abdurrahman? Can Mr. Abdurrahman, on his video so that the Q&A
Mr.
session
Abdurrahman,
yeah.
can you please click your audio and video
Yeah.
on the right? Maybe I try.
So maybe I can announce something related to this presentation. So oral presentations will be evaluated for the awards under 2 categories. So we have one best session presenter that will receive the certificate for best presenter, and I will announce at the end of this session. Best presenter award that offered prize money from 500 to 1,000 ringgit, trophy and award certificate. This will be announced during the closing ceremony. So I would like to seek for your kind cooperation to mute your microphone if you're not presenting, and to avoid any kinds of visual disturbance as possible. So for those who intend to ask questions to presenter, you can channel your questions in Q&A box. I believe most of you will write the questions in the chat box, so that is still okay. So I hope the IT personnel can help me on that. So I will read it after every presentation. You can also request to share your audio and visual to ask questions in the live mode. So that will be better as well. So presenters are given 15 minutes for presentation and 5 minutes for Q&A session. So whereas invited speaker are given 25 minutes for presentations and 5 minutes Q&A sessions. So audio Okay, you can also on your audio and visual to ask your questions in the live mode during the invited speaker presentations. So presenters are given 15 minutes for presentation and 5 minutes. Okay, this is I already mentioned just now. So there will be ring, okay, before the end of your time. So I hope you can, meet this duration. So before we start these parallel sessions, I would appreciate if everybody can turn on the camera for a photo session. So now we have Dr. Malinda. It's just that we don't have Mr. Abdul Rahman yet. Is it possible to have Mr. Abdul Rahman? And then we are also waiting for Dr. Adiola, another invited speaker. Do we have Dr. Adiola?
I'm contact.
Okay, never mind. We take the photo first. I hope IT person can help me on this. Maybe
Yes, sure.
need to
Nurul, can you
stop
please
sharing.
stop?
Yeah, stop sharing first and then take photo. Is it done? Need to mention 1, 2, 3.
Okay, 1, 2, 3. Another. Done.
Okay, good. Alhamdulillah. So now we can move on to the first presenter. We have Mr. Abdurrahman bin Abdurrahim. The topic is removal of heavy metal by emulsion liquid membrane.
Nurul, no sound.
Sorry.
Sound.
You need to click any button to share the sound.
No,
Probably
maybe
you
missed
need to
out.
do that, or you need to, the audio, the setting of your audio.
Sorry.
Zuzi,
How about now?
and liquid
Yes,
membrane
yes,
was
yes.
the of Malaysian
Thank-
International Conference on Nanotechnology and Catalysis. So this is the presentation outline for my presentation today. First, I will start off with the research introduction and background, followed with its objective and scopes, and then the employed methodology, results and discussion, and lastly, conclusion. Firstly, this is the research introduction and background. So in electroplating industries, various heavy metals such as chromium, zinc, nickel, and alloys are used to electroplate metals during the process. From this process, the industry releases heavy metals into the environment via their effluent discharge. As we know, heavy metals are highly toxic and non-biodegradable in the environment. So its exposure to humans can cause various health problems such as acute toxicity, diarrhea, organ damage, anemia, and even fatality. Heavy metals also can bioaccumulate in the environment. Their bioaccumulation can cause death among aquatic animals and impact growth of plants. In order to remove heavy metals, various removal technologies have been studied and developed, such as flotation process, adsorption process, liquid extraction process, ion exchange process, and even ultrafiltration process. In this study, liquid extraction was chosen as the method to remove heavy metals from the environment. So what is liquid extraction process? So in liquid extraction process is a process where two immiscible liquid is mixed and stirred together and will then separated based on their solubilities. So emulsion liquid membrane utilizes this method to extract heavy metals from the feed phase. So there are three main phases in emulsion liquid membrane, which are external phase or the feed phase, and then internal phase or the stripping phase, and membrane phase, which are made up of carrier, surfactant, and diluent. So emulsion can be of single system, for instance, was water in oil emulsion or oil in water emulsion, while double system can be water in water or oil in water in oil emulsion system. For water in oil emulsion happen when the water droplets are dispersed in oil, whereas oil in water emulsion happen when oil droplets are dispersed in water. So this is the illustration of transport of heavy metals ion across the membrane. Since the membrane is selectively permeable, it only allows targeted solute to pass through the membrane. At the membrane external interface, the emulsion globules form a carrier solute complex with the D2EHPA and the carrier molecule transport the solute to the internal interface. At the membrane internal interface, the heavy metal ions are released into the internal phase and the carrier is regenerated into the membrane. In order to form emulsion, these are the chemical constituents that were utilized, which have their own specific function. First, we have the carrier, which carries the solid from the external phase to the internal phase. Next, we have surfactant, which stabilizes the emulsion formed by absorbing water or oil interface. Then we have diluent, which ensure good transport of carrier solid complex across the membrane. And lastly, we have stripper, which is a chemical that extracts solute from the external phase. The surfactant is also called emulsifier. It is a chemical agent that was added into the emulsion, which is a stabilizer by decreasing the interfacial tension between water and oil in the mixture. Surfactant use depends on the emulsion formations. So hydrophilic lipophilic balance, or HLB, is the ratio between the hydrophilic and lipophilic portion of the non-ionic surfactant used. So every surfactant that have their own HLB value, and it can be determined by the following equation. Surfactant with high HLB value are soluble in water, while the one with low HLB value are soluble in oil. So as for the diluents, vegetable oils have been used to replace chemical solvents such as kerosene and hexane as diluents constituents. So vegetable oils are produced from miscellaneous fruits and seeds. It is non-toxic, renewable, and commercially available. Due to this characteristic, they can help to save the environment, promote sustainability, as there will be less natural resources depletions. So in order to choose a suitable vegetable oil as diluent, several properties are observed. The diluent should be of low melting point so that it will remain as liquid at ambient temperature. The diluent also should be of low specific gravity, a value lower than 1, so that it will float on water surface. It should have moderate viscosity, so that emulsion is ensured to be stable and good transport of solute across the membrane. Lastly, diluent with high flash point is favorable as it will be safe to be used without hazard of fire due to the low flammability. So listed in the tables are some of the past studies that have employed emulsion liquid membrane to remove heavy metals such as chromium, cobalt, cadmium, and lead. Various combinations of chemical agents for the emulsion constituent were reported, and the table shows that the extraction efficiencies ranging from 70% to 100% of heavy metal removal. So this are some of the advantages and disadvantages of the heavy metal removal process. First is the flotation, where separation occurs through floating of substance. Ion exchange is the process where we use resin to exchange cation with the heavy metals. That is a chemical precipitation which converts heavy metals to insoluble metal hydroxide using precipitate, and adsorption, which remove heavy metals using adsorbents. So there are several disadvantages on using this chemical treatment. First, they have high operating costs due to the material used. Second, it consumes a lot of energy as some treatment use small units compared to the process to complete the process, and it is also not environmentally friendly and also time consuming. Meanwhile, under liquid extraction treatment process, there are several types of liquid membrane technology, which are bulk liquid membrane and support liquid membrane. Bulk liquid membrane has superior stability, but it has high capital and maintenance costs due to the large amount of solvent used. It also has low flux rate. Flux is the amount of permeate produced per unit surface per time. When flux rate is low, amount of permeate produced will be lesser due to the low interfacial area. Emulsion liquid membrane have been proven to be the best liquid membrane process to extract heavy metals. It has high flux rate due to the high interfacial area. The interfacial area reported to be approximately around 1,000 to 3,000 meters square per meter cube compared to the bulk liquid membrane and the support liquid membrane. It is 40% less cost than the solvent extraction, and solute can be extracted in short time. Emulsion liquid membrane have been applied in separation of organic acid, purification of antibiotics, enzyme catalysis reaction, and blood acidifications. Next is the research objective and scopes. The first objective is to evaluate the performance of green diluents for zinc and lead removal. In emulsion liquid membrane process, liquid extraction method was used where two immiscible liquids are separated based on their solubilities. The membrane phase comprises of carrier, surfactant, and diluent. For the diluent, vegetable oil has been incorporated as an alternative to petroleum derivative solvent, which were corn, palm oil, and olive oil, as they are non-toxic and renewable. The second objective is to study the selectivity of zinc and lead with different carrier concentration using different green diluents. The carrier concentration is the parameter that will be studied in this project. It is to observe its effect on the lead and zinc removal while keeping the other parameter constant. It was varied from 1 volume percent to 6 volume percent using different green diluents. The raffinate that were produced from this process were measured and analyzed using atomic adsorption spectrophotometer. Next is the experimental methodology. It is crucial to identify optimal process parameter involved in emulsion liquid membrane in order to achieve membrane stability and to obtain highest extraction and stripping of metal ions. Some of the parameters are carrier concentration, stripper concentration, surfactant concentration, treat ratio, mixing condition, solute concentration, and the pH of the external phase. In this work, carrier concentration and types of diluent used were the parameter that were varied, while the other parameter were kept constant as to observe the effect on the removal of heavy metal ions. So this is the procedure that have been employed for the emulsion liquid membrane process to extract heavy metals. So first we prepared 10 milliliter of organic phase, which made up of 1 volume percent of carrier concentrations, 2 volume percent of surfactant concentration, and the rest were topped up with diluents. The carrier concentration were varied in the range of 1 volume percent to 6 volume percent. The solution was then mixed with 10 milliliter of 1 molar nitric acid to form a membrane phase. It was stirred using magnetic stirrer at 600 rpm for 45 minutes. So after water in all emulsion is formed, it was then contacted with a 40 milliliter of external phase, which is the heavy metal solution. using a treat ratio of 2:1. The mixture was tested at 600 rpm using 600 rpm for 20 minutes using a magnetic stirrer to form water in water emulsion. So the mixture was then demulsified for 6 hours for phase separation, and the concentration of heavy metals in the raffinate were measured using atomic absorption spectrophotometer. The extraction efficiency was calculated using appropriate formula, and the steps were repeated using different diluents. So this is the results and discussions. The influence of carrier concentration. The graph shows the results on influence of carrier concentration on removal of zinc and lead. For lead removal, the highest extraction was 77.44% using corn oil, 69.34% using olive oil, and 44.61% using palm oil. The optimum carrier concentration for lead removal was 4 volume% for all types of diluents. For zinc removal, highest extraction efficiencies was 80.33% using corn oil, 67.33% using olive oil, and 51.83% using palm oil. Optimum carrier concentration for zinc removal was found to be 3 volume% for all types of diluents. The graph shows the extraction efficiencies of this heavy metal increases with increase in carrier concentration. However, as we increase the carrier concentration, further than the optimum value, which is 4 volume% for Pb and 3 volume% for zinc, the efficiencies of the extraction decreases. So as carrier concentration increases, it is said that large droplets of emulsion are started to form due to the enhancement of ionic charge on the droplets of the emulsions. So larger droplets will have smaller interfacial area, which result in less diffusion of solute across the membrane. Increased carrier concentration also increase the emulsion viscosity, which lead to the swelling of emulsions. So emulsion swelling will dilute the internal phase, and the solid for the heavy metal ion will be released back to the external phase. This will reduce efficiencies of the heavy metals extraction by the emulsion liquid membranes. So comparison with other studies have been made. So Ahmad et al. Have reported that a 98.9% cadmium removal at a carrier concentration of 3 volume% using aliquot T36 as the carrier and corn oil as diluent. Meanwhile, Sabri et al. Reported a 4 volume% of carrier concentration, which is D2EHPA as the carrier and kerosene as the diluent. Next is the influence of types of green diluent used in the emulsion liquid membrane. The graph also shows that for both Pb and zinc removal using emulsion liquid membrane liquid membrane using corn oil performed the highest extraction. Corn oil removed Pb and zinc the best, followed by olive oil and palm oil. It was found out that the viscosity of the vegetable oil affects the extraction efficiencies. Based on the viscosity analysis, corn oil have the lowest viscosity value among the green diluent used. Corn oil have a viscosity of 49 megapascal second, while palm oil have a viscosity of 77 megapascal second. It can be correlated that low viscosity of diluent will result in higher heavy metal extraction and vice versa. Higher emulsion viscosity will increase the mass transfer resistance, which hinders solid transport. It will cause coalescence of the internal phase droplets, resulting in lower interfacial area and swelling of the emulsions. Consequently, emulsion will become unstable and emulsion liquid membrane become inefficient toward heavy metal removal. Ahmad et al. Conducted a similar study using different diluents such as corn oil, sunflower oil, and palm oil. He reported that corn oil performed the highest cadmium removal due to its low viscosity. However, in a chromium extraction study by dust, it was reported that viscosity of the diluent have low effect on the extraction of the heavy metals. So as the conclusion, the study concludes that corn oil is the best diluent to be used in emulsion liquid membrane due to its excellent performance in extracting lead and zinc. It also offers as a greener alternative as it is non-toxic, it is renewable and non-flammable, which are very safe to be utilized in emulsion liquid membrane process. So the optimal carrier concentration for heavy metal removal, which is 4 volume percent for lead and 3 volume percent for zinc. The study also concluded that further increase of carrier concentration than this value for this heavy metal removal will result in emulsion swelling, poor emulsion stability, and inevitably low extraction efficiency. So these are lists that was cited in this study. That is
Okay, so thank you for the presentation, for addressing a very interesting topic, Mr. Abdurrahman. Now, ladies and gentlemen, we have this Q&A session. So you can, open your microphone to ask questions, or you can write your questions in the chat box. So I open everyone to ask questions to Mr. Abdurrahman. Anybody? Dr. Boon, Dr. Malinda, Dr. Zaira. If there is no question yet, so I would like to ask something, Mr. Abdurrahman. Are you there? Okay, so can you hear me, Mr. Abdurrahman? Okay, good. So I would like to ask you something because it is quite new to me that you use this oil in order to extract your heavy metal. So can you just explain again a little bit on how the mechanism occurs, and later on what will happen to the oil and the heavy metals? Are you going to separate them, or what will happen to that extracted? No.
I should refer to the slide, right?
And you can just explain, or if you, I think you can just explain to us to make us really understand about the mechanism.
So as we can see in the slide before, we have four different chemical, right? The oil, the carrier, the surfactant. So in the emulsion liquid membrane, the one that interacting with the heavy metal is the D2EHPA, which is the carrier, and it will interact with the heavy metals and interact, and we stir it together, right? So after sometimes the heavy metal will be transported into the emulsion.
Okay,
From
because
globules,
the
right?
emulsion is like inside is water soluble, outside is the oil. Is it? Is it?
Yeah.
Oh, okay. So it will go inside the water
Yeah.
phase.
Mm-hmm. So after that, it will be demulsified, and then the concentration of heavy metal in the surrounding will decrease, and then we tested that. Concentration.
So if you are going to have a practical application, we have to mix the oil inside the wastewater. Is that what you mean?
Yes.
How to remove the oil later?
The oil can be filtered.
Oh, okay.
Yeah.
Okay, so thank you. How about others? Do you would like to ask questions to Mr. Abdurrahman? Is there any questions in the chat box? Let me see. Okay, there is no question, so never mind. So we can proceed to the second speaker.
There is a question from Dr. Marlinda.
Oh, Dr. Marlinda. Yeah. Where? In the Q&A, is it?
I can read for you. Why span 80 is used in your synthesis instead of another surfactant such as twin 80?
Yeah.
Span 80. I think I have to get back to you on this.
Actually, that question triggered me to ask another question, Mr. Abdurrahman.
Okay.
Another
Okay.
question: you are using a green oil, which is we use as our own. We use it for cooking. So,
Mm-hmm.
what is your comment on this? You are going to have some competition with the food industry. Is that a good way to solve the issue, or what? What is your comment?
Uh, it's not really. It will not become a competition because this diluent, which is the corn oil, palm oil, we can always grow some more corn. We can always grow some more palm, right? So it will not really be a competition except if we use kerosene and hexane that we use petroleum derivative, right? So we deplete the natural resources, so it will be quite a bit of problem. Yeah.
Okay, so thank you, Mr. Abdurrahman. So I think there is no more questions for you. Okay, so let us move on to the second presenter. We have Mrs. Afrin Jahan, and the topic is adsorptive nanocomposite of 2D carbon and amorphous carbon derived from indigenous lignocellulosic residue, present status and future perspective. Okay, please welcome Mrs. Afrin. Can you just click the reading view next to the slideshow button? Next to the slideshow. And this one is okay. Okay, good.
Assalamu alaikum. I'm a very good morning to you all. I am very much honored to present my discussion here in front of all the honorable researchers. I am a PhD student in under Institute of Advanced Studies under Prof. Dr. Mohammad Rafi bin Johan, Dr. Zaira Zaman Chaudhry, and Professor Qazi Muhammad Salim Nawaz. So today my topic is a discussion. Actually, it's adsorptive nanocomposite of 2D carbon and amorphous carbon derived from indigenous cellulosic residue, present status and future perspective. So the main things in my discussion are carbon and lignocellulosic biomass and their action of adsorption. So carbon, as we know, carbon is ruling the world of chemicals, and carbon is often amazing us by new structures and new forms of it. So already we know a lot of carbon forms, like some of them are pictured here, like nanotube, fullerene, diamond, graphite, amorphous carbon, carbon cone, graphene, pentagraphene, these things. But today in my discussion, I will be only focusing on 2D carbon, which is the single layer graphene, and amorphous carbon, which is the activated carbon. Graphene, as we all know, after its advent in 2004, it's been amazing us by all its beautiful features like atomic thickness, electron mobility, strength, toughness, stiffness, high surface area, transparency, thermal conductivity, and so on, electrical resistibility, electrical resistance. And amorphous activated carbon was in research for centuries already, and this is working as an adsorption material. It's because it has other very good features like its radiation stability, low cost of production, high porosity, and it also works as a catalyst carrier. Now the next thing is lignocellulosic biomass. That means the biomass we get from agricultural waste. Every part of the plant can contribute in it. We have tried with leaf, stem, every part of the tree can be converted to carbon. So lignocellulosic biomass are formed of these three parts like lignin, hemicellulose, and cellulose. Cellulose and hemicellulose is a big area of research, and almost 8,000 of publications are from this part. These things are contributing in producing polymer, short and polymer of sugar, and also in creating activated carbon. Lignin, which is comparatively a complex structure, this one is less because of the complexity and because of the cost. This is explored less, and this one also has been used for producing carbon, graphene, nanotube, dye, dispersant, bioplastics, and many things. So how do we convert this waste to wealth? And we go through some process like pyrolysis, hydrothermal activation, and we get activated carbon. Also, this biomass can be pre-treated and converted to nutrient-rich fraction and animal feed. This by other hydrolysis process, and they change to residual fiber and go to activated carbon, which is my concern here. And they also can be converted to biofuel, biodiesel. So biomass, the part which we are converting to activated carbon, is my concern only here. We can do it many ways, like physical activation, which we call heating through pyrolysis. Pyrolysis can be of three types, like flash pyrolysis, which we do in a very quick temperature rate, and the temperature goes above 700. 700 to till 1000, and it can be slow pyrolysis also, which gives us char, and that one is a slow temperature rate, and that one also works as an absorptive material. Also fast pyrolysis is also there, where we keep the temperature above 600 to above 500 to 800, 900. We also can activate a biomass by chemical activation, where we do by potassium hydroxide, any salt or acid or base, all can work. We also are taking currently the two steps method, like physiochemical activation. There we do pyrolysis and chemical activation both together to ensure that the surface area is properly having proper pores and very good for absorption. There is another way, which is a very quick one, is microwave assisted method. This one also gives us very good pore. So now this amorphous carbon from biomass and graphene, these all have been used for treating the water. They have many other application also, but my concern is only on water. So from water, the pollutants are many types, like can be antibiotic there. There are other pollutants like dye, like protein, like normal residue. So these can be absorbed, which are molecular size. Those need to be absorbed, and this absorption is done by majorly now by activated carbon. Activated carbon by adsorption process. There are other processes also, like oxidation, ion exchange, reverse osmosis, ozonation, advanced oxidation, photocatalytics. But this process is industrially very popular, and this process is giving us still now very good result. So I'm focusing on this. So adsorption by activated carbon, as you can see here, it's just the molecules are adsorbed in the surface, and when we do it, do convert it to the we see the isotherm, we get this slope 1/n is less than 1, then we understand that the adsorption is good. This adsorption is effective, as I said, because of economic method, very economic way, and very effective as well for heavy metal and organic compounds. So when we do the adsorption with activated carbon, we get something like this, because carbon is a combination of mesopore, micropore. So it can also absorb the large organic molecules, small molecules, dyes, many kind of things, but maybe very, very small ones are not for activated carbon. When we see it under SEM, we can see the pores like this, which actually hold the organic molecules, and they are absorbed, they are gone from water. Now, same absorption when we tried with graphene or graphene oxide. Here is a schematic for graphene oxide. Here you see the graphene already have some functionals, and here is a methylene blue dye molecule. These functionals actually get attached to this this dye, and that's how this is absorbed. This is not in a pore. So this graphene absorption is very quick compared to carbon, very quick and very efficient, but maybe this cannot hold the large molecules for long. So this can reverse to the water back. But the amount of graphene required for adsorption and the time it requires for adsorption is amazing. That's why if we go through the literature, we can see that the almost everything available, every available lignocellulosic biomass have been turned to carbon, and we have got the absorption capacity very good. Like rice husk gives good result, granular sludge also good gives good result, nutshells give good result. So these all are done absorption. And here we see when we are doing the adsorption by functional graphene, mainly for the antibiotics, this adsorption is also very good. For graphene is working like graphene oxide, graphene composite with other graphene oxide with other catalysts here, all are giving good result. Now, when we are here also there are some more antibiotics. So these two are doing very good when graphene, these two are very good, doing very good in their own way, but both of them are having some limitations. As I said, like activated carbon cannot absorb the small molecules, and graphene cannot absorb the bigger molecules, and it cannot do the stable adsorption. Now, here also some literature from the literature we have found the graphene-based adsorption. Different heavy metals are absorbed by graphene very efficiently. So if we compare the adsorption for heavy metal by graphene oxide, CNT, and activated carbon, here as you see that the adsorption by graphene oxide is higher. And here also. So here also we can see that the activated carbon BT surface area and graphene oxide BT surface area has a very big difference. Like graphene oxide surface area is said that like 134 gram of graphene can cover a big saucer area, saucer ground. But activated carbon surface area is stable but smaller. So researchers have analyzing both of these. Researchers have thought that we should have a way to combine both to get the both good parts together, and that's why the term came that amorphous carbon and graphene composite. Researchers, this research is already in electrode, and they have done the composition by these methods, but very few literature is there for adsorption. Like here is a proposed one where they are using TEOS, and it's treated by water and ethanol, then it gets the functional. This functional is mixed with graphene and activated carbon, and together this composite works as a very good adsorptive material. Now this one is supposed to have a schematic structure like this, activated carbon and graphene. So this one is done simple step. I have found very few literature on this, and simple step mixing they have done, and they got a graphene oxide and activated carbon monolayer. And when they tried the adsorption, they have found this kind of very good result. As you see, the adsorption is done very quick and a very, very high rate. Now, when they have from those reports, we can compare here graphene and activated carbon composite absorption is this high, whereas the others are not that high. Pure graphene is high, but pure graphene is actually not stable. Here in the FTIR also, you can see it has absorbed the whole of dye. Another literature has proposed of also direct mixing, and they have also received very good result on this graphene oxide and activated carbon composite. Here you can see they have reached maximum 1000 absorption capacity, and but they have found that they can do good for cationic dye, and they could not do good for anionic dye. One reason can be that whenever a graphene and activated carbon together, whenever a graphene and activated carbon are mixed together, then the surface area actually decreases. When it decreases, then maybe the functionals first attack the dye or the pollutant, then by the electroionic charge, the base becomes charged, and that's how the dye later falls on the carbon surface. So that's why it can be the reason. So this current status is, I have found very little amount of literature on this, and they are facing many problems like the particle size, they cannot control it, agglomeration happening because of nano, and the particle size and the temperature is also a matter there. If temperature is high, the agglomeration goes higher. Stirring speed, mechanical force, pressure, and process of activating the carbon, all these things are contributing in the composite. So these all can be done by machine learning, and this can be optimized, and I see very good prospect of it. Like compared to all other spacer materials, graphene is a very good spacer, and if activated carbon is used with graphene, then it is compared to the graphene metal oxide, graphene polymer, this is a facile, green, low cost, and scalable route. Also, the selective adsorption is also happening here. As I said, that it's taking the cationic dye, cannot take the anionic dye yet. So we can work on that too. Here, activated charcoal has a huge surface area, but as I said, when it goes composed with graphene oxide, the area decreases. That is as well a good sign, because then the composite is able to hold antibiotics and very smaller particles as well. So it will be a very good adsorption. And here, in the composite, both are ruling. So no one is dominating. That's why in this composite, the common problem with graphene we face is that whenever graphene is producing, the structural disorder is very common thing. So for composite, this won't affect us. And this also solves the huge lignocellulosic waste, and by adjusting the amount of carbon and graphene ratio, we can also minimize the cost of graphene, and so the water pollution and absorption can be done very nicely. Thank you very much.
Thank you, Mrs. Afrin Jahan. So now we move to the Q&A session. So is there any questions from the evaluators, other speakers?
There's a question in Q&A box, right?
Q&A, okay. So this is from Dr. Malinda. Hi, Mrs. Afrin. Graphene sheets are less functional group that attach to it. How do you make the composite with another nanoparticles? Is there any pre-treatment use?
This composite we are going to make with activated carbon. So that is activated. So that's why in between the layers of graphene, they just have in between the layers of graphene, they can stay inside. That's how the layers are formed. Because of it's being activated, so the weak van der Waals is working there.
Okay, I have a question. So you have graphene oxide. You would like to combine graphene oxide and also activated carbon. And I believe
Yes.
activated carbon will be activated by some OH functional group.
No. Activated carbon activated by heating.
Oh, heating. So there will be no OH. So that's why you are going to use.
There will be. We actually, when we tried, I could not show my results because of the pandemic. I could not have any characterization, but I have done the composite. So whenever we do the composite, first we make the carbon by two-step, like we do KOH and we do the heating. After that, separately we do the functionalization of graphene. Then we just mix together.
So because when you add KOH, so I believe that you are going to have OH functional group on your activated carbon, right?
Yes.
So you said just now that GO has a better absorption as compared to this activated carbon with OH functional group. So why
Yes, but
is
not
that?
stable.
Why is that? What is the main reason for that? For far enhancement in the absorption?
Or because the graphene is much more electroconductive, and graphene surface area is also very high because of the nano size.
Because all right. Is there any oxygen rules there because you are using graphene oxide, or later on it's going to be reduced?
No, we don't reduce, but this works as functionals for holding the external particles.
Oh, so have you come across that the rules of the oxide actually improve the absorption? Not
Yes.
many. Yeah. So
yes,
okay,
if the graphene is not functionalized, then the result is not that good. But if functionalized, then the result is very good.
Okay. So thank you, Mrs. Afrin Jahan. So I believe we already completed with the speakers. Now we are going to move on to the invited
Rika,
speakers.
excuse me.
Yeah.
I have one more question.
Oh, sorry.
Yes,
Dr.
yes.
Marina, say you can ask. Sorry.
Okay, all right. So Afrin, you mentioned just now that you are using the single layer of graphene, right?
Single layer graphene.
Yeah.
No, graphene nanoparticle.
Graphene nanoparticle. So how do you confirm that graphene nanoparticle is there any specific test that you have done to confirm the graphene nanoparticle?
Oh, graphene nanoparticle, I have done the size test, but we use the graphene nanoparticle, commercial graphene nanoparticle, we just functionalize it.
So do you just confer it just from the description from the receiving, or do you make another confirmation from that?
So for the size I did.
So
for the size I did, and it's 70 nanometer maximum.
I see. So is there any like Raman test you test
No,
on
I
that?
could not do any characterization yet. I'm waiting.
Oh, I see. So my suggestion is that for the characterization test, you are maybe you can do for the Raman test, because graphene, the most suitable test, I think Raman, you can check on the intensity, and then normally like intensity of 2D over intensity of G, then you can see what is that actually
we have a plan to do.
Yeah.
Raman, thank you, Dr.
All right, okay, thank you.
Okay, thank you, Dr. Malinda. Thank you, Mrs. Afrin, for the interesting talk. And now, I would like to move on to, let us move on to the invited speaker. We have Dr. Adiola Akinpelu, and the topic is about adsorptive removal of polycyclic aromatic hydrocarbons from contaminated water by biomass from dead leaf of Halodul Uninervis, Kinetics and Thermodynamic Studies. All right. Okay. So please welcome Dr. Adiola. Dr. Adiola.
Thanks for having me.
Yeah.
Thank you very much. Okay.
All right.
So how do I share my screen from here?
There is a button, laptop there, or monitor. You can click that one. At the bottom, you can see the button of monitor next to the button of microphone.
Okay, yeah, I can see.
Okay, you click that one and you share your slide.
Okay, I can see. Can you ask my screen?
Okay, yes, okay. Okay. So can you make it into presentation slide?
Can you see it now? Is it okay?
Yeah. Okay. Good.
Okay. Yeah. Good morning, everyone, and thanks for having me. It's a pleasure to be with you today. July this year, I saw a news from the US that a particular county was going to go for desalination option because of predicted freshwater drought. That is in county called Marin. I think that should be in California. As this was not enough, another county in August this year again awarded another project of 4.1 billion desalination plant. That's another backup plan for predicted freshwater drought. This event in US and many other places around the world clearly shows that there's a serious stress on the global freshwater supply. And this is not unexpected. We do know that 95% of global water is in form of saline water. Therefore, we cannot really use them for our daily need, such as drinking, washing, etc. And 4% of global water is in form of glaciers. So we cannot really access them as such. And it is just 1% of global water is in form of fresh water that a lot of several billions of people are depending on for their needs. And you know what? This 1% is under continuous contamination from both inorganic and organic pollutants, such as polycyclic aromatic hydrocarbon. So we have a situation where we have water everywhere, but it is becoming more difficult for us to get a clean drop of water to drink or to use. As a result, there have been many advocacies to challenge this status quo. One of it is reduce, reuse, and recycle. I like reduce. However, if individual reduces his or our wastewater generation, it will not translate to total global wastewater generated. It will not translate to any reduction in total wastewater generated by the whole world. Because as we do know that as the global population is increasing, associated wastewater will also be increasing as well. So it is becoming more difficult for us to go through this route. Therefore, one of the sustainable way to address this problem is to create use for our wastewater generation. That is why today I'll be talking about how to reuse our wastewater generation through the use of powder from dead leaf of Allodule uninavis to remove polyaromatic hydrocarbon pollutant from wastewater. So this is the background of this is outlines of my discussion, and I hope I will be able to finish everything, inshallah. About PAH. You know, PAH, they are called polycyclic aromatic hydrocarbon, and they are non-persistent organic pollutant. They are highly toxic and they are carcinogenic. That is why many countries and international agencies have subjected PAH to stronger legislative control. Countries like Italy, we have EU, we have WHO, and we have US EPA. They have listed 16 PAH as priority pollutant. We have two forms of PAH. One is petrogenic, another one is pyrogenic. Petrogenic PAH, they are present in petroleum and some petroleum hydrocarbons. They are known to be light molecular weight PAH. They are less toxic. Examples of them are naphthalene, fluorine as a naphthalene, etc. Another form of PAH is pyrogenic PAH, which are formed from incomplete combustion of organic material or hydrocarbon. They are known to be high molecular weight PAH, and they are more toxic. The example of them are benzo-K fluoramphene, benzo-A pyrene, benzo-GHI perilene, etc. Actually, we have more than 16 listed priority pollutant, PAH priority pollutant. but it will be very difficult for me to go through them, all of them, in one presentation. So therefore, I've decided to take 3 as model pH compound to study. They are asenaphthalene, phenanthrene, fluoranthene. This one are chosen because of their higher relative solubility in water. Therefore, we are more likely to be exposed to them in our interaction with water or wastewater. And going through incident report in Malaysia as a case study. 2 decades ago, major form of pH reported, they were in form of petrogenic pH. Therefore, they were less toxic. But over the span of 2 decades, we've seen a transition from petrogenic pH to pyrogenic pH. And this is more worrisome because we do know that pyrogenic pH is more carcinogenic than petrogenic pH. However, this is not peculiar to Malaysia alone, because any country that is witnessing industrialization will also go through this cycle. So and we do know that over the 2 decades ago, Malaysia has witnessed a lot of industrializations. That is why the nature of the pH that we are reporting in Malaysia to us are changing from petrogenic to pyrogenic pH. There have been a number of reports where increased lung cancer risk, increased skin cancer risk, and increased bladder cancer risk have been associated to occupational exposure to pH among the workers that are working in companies like aluminum, gold classification, coke productions company, China, in countries like China, Italy, Netherlands, Japan, US, Canada, France, Sweden. So the full report about this study can be seen in this publication. It's a very nice publication for us to see, where it was reported, actual case of increased cancer risk among the workers that are exposed to pH in their occupation. As a result, there have been several efforts among the scientists, among scientific community, on the way to remove some organic pollutants from our wastewater. Some of these methods, some of these ways, some of them are costly. Some of them, they take time. That is why attention has been shifted towards adsorption, because it is very cheap, eco-friendly, and it doesn't really have major side effect or side byproduct. So like we do know, adsorption is very simple to operate and design. It is environmentally friendly and it is low cost. When we're talking about adsorptions, it can go through 3 different ways. Like visorption, it can be through chemisorption, it can be through ion exchange. However, in adsorption, the most important part of adsorption is adsorbent. This is critical part of adsorptions. And going through the literatures and in the market as well, many of the available adsorbents that are reported in the literature, some of them are very costly. If the production of some of them also generate another byproduct that are more toxic for us. So that is why using of a biomass is becoming more important now to use as adsorbent to remove pollutant in the wastewater. One of such biomass is dead seagrass. And we know seagrass are their flowering plant. We have 72 known species of them. We have 0.1 to 0.2. They cover 0.1 to 0.2% of the global ocean. That is a lot. And they form food for some of the coast marine organisms. Not only that, they also help our environment by sinking some of the greenhouse gases, CO2. And the value of the seagrass per meter square is around 172 pounds. However, annually, this seagrass, their leaves detach from the stem and accumulate at the coastal line. And it is known or estimated that 1 kilometer of seagrass can produce 125 kilograms of biomass every year. And These biomass, they are piled up along the coastal line, and usually they are disposed of in the landfills or biomass waste facilities. These management practices implies a lot of environmental and economic cost. And not only that, the degradation or decomposition of this biomass also emit greenhouse gases in form of methane. And in addition to that, the decomposition of this biomass also generate hydrogen sulfide, which is very toxic. That's why it's very important for us to create wealth or to create use for this particular pollutant. We do know that pollution is nothing but the resources we are not harvesting. We allow them to disperse because we've been ignorant of their use, a quote. And going through the history, we do know that conversion of waste material into wealth is not new or peculiar to our generation alone. In fact, I can say, in my own opinion, conversion of waste material into wealth is a legacy of our older generations that we refuse to advance better. 3 centuries ago, we could imagine that human waste, human poo, was being displayed in public market as a commodity to buy in public market. A case in point is what happened in Japan, while human waste was called night soil, and it was a commodity that everybody was looking after to buy. So, in fact, if you look at literature, according to my own understanding, in my own opinion, there was not much noise about waste management in our older generations. It was not, because it was never an issue within them. They had their own natural way of converting their waste into wealth. Unfortunately, it's a legacy that we refuse to advance further. That is why, looking at this, we believe that we should create a use or a wealth from biomass of dead seagrass. And looking at scientific community, this has been done in 2 ways: energy conversion and biochar for adsorbent. Energy conversion, for example, there is methane generation plant for biomass from dead seagrass, and it is estimated that around 250,000 Newton meter cube of methane is generated from biomass of seagrass. And the digestate can also be used as fertilizer. And economic value of around 33,000 pounds a year can also be generated from this. And more importantly, actual landfill cost of about 200,000 will be avoided every year. However, our interest in this discussion is using them as adsorbents. And we do know that global market for acrylic carbon was around 4.7 billion in 2015. And it was projected to reach 8.1 billion this year. So we believe if you can develop allodelay nanoviscs, it can also take part of this market share, because we do know that 1 kilometer of seagrass can generate 1 to 5 kilograms of biomass. So in the literature, people have used this particular material for different applications, and they've used them to remove some of inorganic pollutants and organic pollutants. But what is unique about this study is nobody has reported the use of this particular biomass to remove polycyclic aromatic hydrocarbon from water. So this is what you want to do. And this is the setup. And from this setup, we're able to do kinetic study, acetylene study, and thermodynamic study, and aesthetics study. And from the characterization, I mean, we do know that this is a biomass. It is not really treated. So we expect that there will be a number of functional groups on them, like OH, like aromatic ring stretching, like lignin and aliphatic stretching. And from surface area point of view, we found that it was around 30.95 meters square per gram. Proximate analysis shows that carbon is the majority content of this biomass, which is expected. I mean, it is normal. And from the SCM image, for now, it shows to be a fibrous and with some mesopause structure. The first experiment we did was to study the effect of dosage. because we do know that one of the parameters that govern adsorbent cost is the dosage. So the dosage, one of the parameters that governs the cost of any adsorbent is the dosage. Therefore, we vary the dose from 5 milligram to 300 milligram. And as we varied the dose, removal efficiency was increasing until it reached maximum at 100 milligram. And at this optimum dose, fluoranthene has the highest removal efficiency, followed by phenanthrene, followed by then acenaphthylline. Then we went to kinetics. In kinetics, it's very important for industries to know how many cycles of operation they can do on any adsorbent per day. So one of the experiments to determine this is kinetic study. So by benefit of, therefore, it is very important to the industries to know the number of cycles they can do per day, and they want running cost, and they also have interest to know the adsorbent cost. So the experiments to determine all this is known to be kinetic. So in this experiment, we varied the time from 5 minutes to 12,500 minutes. And fluoranthene was able to reach equilibrium around 6 hours, followed by phenanthrene, which reached equilibrium around 24 hours, and acenaphthylline, which reached equilibrium around 120 hours. What we do know from the structure, possible explanation for this is the structure of this compound. We do know that fluoranthene has highest number of ring among the 3 compounds. Therefore, there are more possibility for them to have high number of interaction sites to interact with the adsorbent. Therefore, this has been helping their interaction with the adsorbent, and therefore it has been maybe it may be responsible for the highest removal efficiency witnessed by the fluoranthene. So the next in line is phenanthrene. Then the last one is acenaphthylline, in that order. And from the kinetic, we also use 4 models. We also use 4 models to interpret kinetic behavior of this adsorption. First one is first order, interparticle diversion and elevation. And the best model to interpret kinetic data of this experiment is second order, with highest correlation, and the difference between the predicted values of QE and experimental value is very, very minimal. Then we also went further to do isotime study. And from the study, we used 3 different models: Lagma, Freundlich, and Temkin. And we also tried to use their linear form and nonlinear form. Recently, nonlinear form is gaining more momentum among the scientific community because it is less biased compared to linear form. And from what we can see here, Freundlich happens to be the best model to describe the isotime of this pH on the adsorbent. And of course, from the nonlinear point of view, Langma and Temke did not do badly bad either. So this suggests that we can have coexistence of many mechanisms responsible for adsorption of this pH on the adsorbent. And from the curve, we do see that the nature of the curve also shows that it is favorable for adsorption to take place between this pH and the adsorbent. Recently, scientific community, they are having interest to know the contamination tendency of any adsorbent to release some of the adsorbate back into the parent solutions. And one of the experiments to determine this is called hysteresis analysis. They will really want to know, is it possible for the adsorbent to recontaminate back the parent solutions? So, and they do this experiment to determine the potency of any adsorbents to hold strongly the adsorbate so that there will not be any recontamination. And the value they normally look for is around this hysteresis index. So any value around 1, 0, or negative shows that that particular adsorbent is not really good at holding up the adsorbent strongly, and therefore it can easily contaminate the adsorbent the parent solutions. And from what we can see here, we see that our values are far away from either 1 or 0 or negative. Therefore, it shows that this particular adsorbent can hold strongly the 3 model pH that we studied in this study. And from thermodynamic point of view, we vary the temperature to see thermodynamic behavior of this experiment, of this adsorption. And we do know that, for example, we discovered that delta G were all negative for phenanthrene and fluoranthene, which shows that they were all spontaneous at this different temperature. However, for arsenic-phthalate, it was negative at lower temperature and it became positive at higher temperature, which shows that they are spontaneous at lower temperature and spontaneous at higher temperature. And data H2, the change in health therapy also showed negative values, which shows that the exothermic adsorption process. And but for arsenic-phthalate, the exothermic is very high, which shows that maybe there's some form of chemisorptions in the adsorption process. And comparing this adsorbent with other reported adsorbents in the literature, we do know that this particular seagrass powder can compete favorably with many reported adsorbents in the literature. However, the fair comparison would be between this and other biomass, similar biomass. And from what we can see here, we can see that from point of view of QE, we can see that this particular biomass, our biomass, is very good compared to many other biomass reported in the literature. It does even better than many other biomass reported in the literature. This is the research outcome from this work, and we still have more work to cover in this particular research. And our future work is we are planning to do a mild modification of this adsorbent, and we want to use AI to design and experimental designer to design the experiment, and want to get closer to the real-life application by exposing this experiment to column adsorption experiments. Conclusion from this work is we do know that this particular powder from the dead aludule universal leaves can remove pH from contaminated water, and 100 milligram happen to be the optimum dose to remove fluoranthene, phenanthrene, and naphthalene. And we suspected that there is coexistence of heterogeneous adsorption mechanisms. And so the second order equation model kinetic data very well for each of the compound. And the aesthetics index showed that the strongest attraction existed between fluoranthene and the adsorbent, followed by phenanthrene, then followed by arsenic-phthalate. And the adsorption case of this compound on seagrass is spontaneous and exothermic. Thank you for having me, and your question. Welcome.
Thank you, Dr. Adiola, for the interesting topic and studies that you have, your data, everything. So I am impressed with the results. So is there any question from the speakers here? And Dr. Malinda, you would like to, do you like to add something?
I have this is common question for me because I'm not related much about the biofuels and also biomass. So for your opinion, what is the initial step that need to be studied? Is it the material of choice or is it the processes? Thank you.
Again, sorry for the question. Sorry. Again, sorry.
Okay, I just want to know for the beginning of the study, for the initial step, what is the things that need to be considered first? Is it the material of choice, or is it the procedure or step, or in order to study the best optimum result
Yeah,
in this biodiesel?
yeah, of course, it's the material.
Okay.
Is the material in this context is the material, yeah.
Okay, thank you, Dr. Adiola. So since
Thank
we
you,
are
sir.
quite delayed in time, so I think we can move on to the next invited speaker. We have Dr. Zaira Zaman Chaudhry, and the topic is environmental perspective and toxicity profile of potential surface engineered carbon and its derivative. So please welcome Dr. Zaira.
Thanks a lot, Doctor. Actually, the video presentation is there.
Okay. So, right.
Okay, wait, yeah, maybe Madam Afri is going to refresh.
My presentation is with Afrin, so I think she has to refresh, and now we can see Adiola's screen.
Nanotechnology and Catalysis Research Center. Today my topic is environmental part. Assalamu alaikum. This is Dr. Zaira Zaman Chaudhry from Nanotechnology and Catalysis Research Center. Today my topic is environmental perspective and toxicity.
Sorry to interrupt. Is it can you hear and see also?
Yes, Afrin, from my side, I can.
Okay.
Profile and for potential surface engineered carbon and its derivatives. My presentation will be divided into 6 sectors, that is introduction, methodology, absorption technique, results and discussion, and conclusion. If we see the carbon, we can see that there are mainly the carbon can be divided into nanocarbon or amorphous phase carbon. Now under the nanocarbon, we have carbon nanotube, which can be single wall or multiple wall, and then we can go for graphene, which is 2D structure, and then we can go for fullerene. This is our 3D carbon. And activated carbon, biochar or carbon black, these are our amorphous phase carbon. Now if we talk about nanocarbon versus activated carbon, which one should be more convenient for using adsorption experiment for wastewater treatment, then obviously it will be, the answer will be activated carbon. Because why? Because nanocarbon are costly and it has toxic effects. Separation from them need special technique, that is centrifugation. So, but activated carbon can be separated from the wastewater after the pollutant adsorbent by simple filtration process. So this is surface engineered activated carbon. Why we call surface engineered carbon? Because we can control its porous structure. Based on our interest, we can control its porosity. We can control its surface functional group also. Activated carbon is mainly composed of carbon, but it has some ash residues, which is considered as pollutant here. If we see activated carbon properties, this is considered as mother nature purifier because it can withstand very high temperature, it is resistant to acidic and basic media, and it has very high surface area. It has very high iodine number also. So it is easy to design, it has more surface area, we can change its surface properties and regeneration. Activated carbon can be powdered, granular, and fibrous activated carbon. We are preparing here powdered activated carbon. Activated carbon has 3 types of pores, micropore and mesopore, which will be contributing to our absorption process for pollutant removal. Macropores are acting as tunnel between micro and mesopores. We are preparing the char before the activated carbon synthesis. That one is also useful. That one can be used as a soil fertilizer. If we consider the activated carbon preparation process, there is 4 types of thermochemical process: pyrolysis, torrefaction, hydrothermal, and combustion. These are divided according to the temperature range. So if we see the pyrolysis process, this can be fast and slow. We are interested here for slow pyrolysis process for carbonization. That is our first step of preparation. Then we will go for activation process. So this is the temperature range for thermochemical process. We can see that biochar preparation through torrefaction and carbonization using slow pyrolysis has also some advantage. It will give less star inside the activated carbon, and we can see that H by C and O by C ratio will decrease with increase of temperature. That means our carbon proportion will be increased. This is hydrothermal carbonization. Sometimes we do it as preliminary step. Here water is acting as a green catalyst, and it will be divided into OH and H plus ion at high pressure, and it can disintegrate the biomass substrate into hydrothermal carbon or hydrochar. So this is CNT preparation method. The first two is very costly method, arc discharge and laser furnace. This one is used for industries, but laboratory scale we can prepare chemical vapor deposition. But chemical vapor deposition process, we have to use a catalyst, that is metal catalyst with hydrocarbon source, and we can get CNT growth over the activated carbon. Now CNT and graphene has, what is the disadvantage? As I told earlier, that adsorption process needs separation of the carbon. So this one difficult for CNT and graphene, and weight loss is there. And then we have to control its surface functional group. If the growth mechanism is not controlled, then over the CNTs we can get some metallic pollutant. So what happened? This one we are introducing secondary pollutant in nature. So if we consider the critical factor for CNTs, we can see that if there is any types of microbe present, then what happens? CNT surface will be changed, and there will be hydroxide and hydrogen peroxide radical, and this one will convert the CNTs to carboxylated CNTs, which is hydrophilic in nature, and separation of them from water is very difficult. There is humic acid and tannic acid present in wastewater also. This will change CNTs properties, and then it will be too much stable in environment. CNTs or graphene can be used for nanomembrane synthesis, photocatalyst, or catalytic wet air oxidation process for water treatment. Because in membrane, when nanocarbon are used, they can resist biofouling process because they will destroy the bacterial cell. It is very efficient photocatalyst, and it is very good for catalytic wet air oxidation also. But we have to consider in both cases the toxicity of the end product, because there will be after some degraded compound present in water. Okay? So in membrane synthesis, as I mentioned earlier, it is positive because we can increase the water flux as well as decrease the biofouling tendency if we use nanoporous carbon in membrane. So nanotoxicity clock, if we consider for nanoporous carbon, we have to see a lot of factors, that what metal is dropped over the CNTs, whether it is leaching free or not, what type of functional groups are attached, which types of CNTs are used, is there any impurities or not, and what is the functional group there, whether the CNTs are hydrophilic or hydrophobic. These things we have to consider. Now CNT or nanocarbon can be dispersed easily to the environment. That is for their volume to surface area ratio, which is very high. If we see the application of nanocarbon, we can see that it is widely used in soil for increasing crop yield. It is also used as solvent also. It is used for environmental sensing also. When using in agricultural sector, we have to see the length, degree of aggregation, surface functionalization strategies for CNTs, and then we can use it in agricultural sector. Here is literature review. We can see size of nanoparticles, concentration, germination, medium, and exposure. These 4 factors are together to determine whether the nanoporous carbon will have effect on seed germination or not, whether this effect will be positive or negative. This is a table that it is showing the concentration range of using fullerene, graphene, and nanotube. If we go for heavy metal, why we are removing heavy metal? And we are particularly interested here to remove the lead to cation from wastewater. It has actually carcinogenic properties, and it is mutagenic also. It inhibit our enzyme preparation, and it inhibit our metabolism process, and the bone structure will be destroyed. So that is the reason we have to remove the lead from water. So if we consider the environmental pathways and fate of heavy metal in water, we can see that these are very persistent, and this has bioaccumulating tendencies. From soil sediment, it can go to the highest chain of the food, highest member of the food chain, that is to us. So our objective is to prepare activated carbon by two-step method to optimize the process parameter and see the effect of activated carbon for lead to cation removal. Of course, for adsorption process, we will determine the kinetics and isotherm parameters. So if we see the research gap, we can see that what is the wood quality? These two wood chips, whatever we have chosen, has been used very less in literature. How to optimize the process parameters, and we are using potassium carbonate, which is a weak activating agent, not like harsh chemical like phosphoric acid or potassium hydroxide. So this one has impact on microwave-assisted pyrolysis or not. So if we go our methodology, this is our methodology, simple layout of the methodology. Let us see that why we are interested for physiochemical method. It is two-step method. It will give clean carbon because there will be less star formation. It is two-step process. And in the secondary step for activation, we will use microwave-assisted pyrolysis because microwave-assisted pyrolysis will ensure volumetric heating, and with, in very small amount of time, and the sample will be heated up. This is our fixed bed apparatus. After this fixed bed pyrolysis process, we will get the char, which we will mix up with potassium carbonate, reflux it for 6 hours at 70 degrees centigrade. We will get the impregnated char. This impregnated char we will put into the microwave to activate it and get our activated carbon. Both char and activated carbon we will characterize and go for removal of lead cation removal. So here the pyrolysis process, as we told earlier, we are interested for slow pyrolysis when the temperature is increasing slowly into the reactor, that is 5 degrees centigrade per minute. This is our microwave assisted setup. This is Box Ben Hanken design. RSM process has been used. This is our input variable, power, radiation time, and ratio. And our desired output is removal percentage, active carbon content percentage, and yield percentage. We want these three output variables to be maximum. So if we consider this design matrix, we can see that sample number 6 has shown maximum removal percentage and fixed carbon, and sample number 11 has shown maximum yield percentage. So we have to optimize the process. This is a software suggested optimization process. We have carried out this reaction, and then we saw that our predicted our experimental result is slightly deviated from the predicted one by the software. This is the quadratic equation suggested by the software. This is if we consider the predicted versus actual removal percentage and yield percentage and carbon percentage, we can get this diagram from the software. We can see that our experimental points are nearby the linear line. This is the RSM plot. We can see as much as we are increasing the power, our removal percentage is decreasing. The same thing happening for carbon yield and same thing happening for fixed carbon. This is quite normal because when power is increasing, the active carbon network or the skeleton will be destroyed and there will be more ash formation. The micropore will be first converted to mesopore and then it will burst out to macropores. And we know that macropores are not contributing into the adsorption process. This is our surface FESM. We can see that the first picture is our raw biomass. We can see critical layer which is quite smooth and there is no pore, and after carbonization small amount of pore has been developed, and after activation there is lot of pores. Inside the micropore wall there is inside the mesopore wall there is micropores also. This is BET surface area analysis. We can see that BET surface area increased from 448.79 degrees and 79 meters per gram until 1390.76. This is ultimate analysis and proximate analysis. Proximate analysis is our PG analysis. We can see that carbon content from raw biomass was 51.92 and it was increased to 80.02. Similarly, ultimate analysis shows that percentage carbon increased from 50.87 to 81.99. This is our XRD analysis. We can see P is our char and C is our carbon. Both of them is amorphous. That's why blunt P. But A is our biomass, which has cellulose, and cellulose has amorphous, and crystalline peak. So that's why there is 2 peak. We are going for adsorption process, which is surface phenomenon. The pollutant will be aggregated over the surface, but to some extent adsorption will be taking place. There is 2 types of adsorption. We are interested for chemical adsorption, and for that we will do the adsorption kinetics analysis. Kinetics we will go for pseudo first, pseudo second, Lignocellulosic equation, and intraparticle diffusion. Now here, if we see, this is our adsorption experiment setup. Now, adsorption experiment, there are a lot of variable: contact time, concentration, pH, temperature, and amount of carbon added into the wastewater stream. Adsorption equilibrium, we need to know the adsorption equilibrium time so that we can remove the carbon, because carbon is exhausted now after the equilibrium time, and then we can regenerate it. This is some basic terms. When there is C, we have to think that C denotes the liquid phase concentration of the pollutant. Q denotes the solid phase concentration of the pollutant. This is pseudo first order reaction equation, and there is equation constant K1. Pseudo second order reaction. Pseudo first order is less desirable as it is happening for physical adsorption. Pseudo second order is more desirable, which is also desirable because this is showing chemical adsorption, which is irreversible. Intraparticle diffusion is checked that whether there is adsorption process taking place or not. That means inside the core, any pollutant gone through or not. This is adsorption isotherm. Lannu is checked for maximum monolayer adsorption capacity. Friendlich is checked for affinity factor, and Chemkin is checked for CV and QE relationship with temperature. So for adsorption intensification process, we can see that we have to go for adsorbent synthesis, we have to do the process optimization, then we have to go for modeling process. And then after getting the optimum carbon, we have to go for adsorption test, we have to regenerate it, and we have to analyze it life cycle, how we have to use the regenerated carbon for life cycle. So this is the way we have to go for adsorption experiment by synthesizing structured carbon. Thank you all. Thank you for listening to me. This is my email. You can contact me if any queries. Thank you all, and Assalamualaikum.
Thank you, Dr. Zaira. Even though it is a recorded presentation, but I learned a lot from it, and I try to catch as many as possible information, which is good for the study. So I open to all. If you have any questions, you can ask Dr. Zaira. Let me check if there are any questions in the chat box. Okay, so there is no questions in the chat box. Probably Mrs. Afrin, you would like to ask something? Or Dr. Adiola?
Okay, so I might like to know why the microwave assisted. How does the microwave assisted carbonization work?
Microwave assisted carbonization or activation is a new technique. It is a comparatively new technique. We could have used stick pyrolysis or slow pyrolysis, but we didn't use it because microwave, what happened? Just consider.
Doctor, the sound is broken.
The sound broken. Now I think the phone is nearby. Now it's okay, right?
Okay.
It's okay. Okay, let's see. Microwave, there is energy passing through, right? For energy, what happens inside the matrix, inside the biochar matrix, what happens? There is dipole moment. There is more magnetic force. There is more oscillating force. So what happened at once? The temperature will be increased within 5 to 10 minutes. We can check it by thermocouple. In the microwave, I have shown the setup. We can check it by thermocouple that in 10 to 15 minutes, the temperature will raise very, very high. And what happens is microwave assisted pyrolysis, another name is volumetric heating process. But conventional pyrolysis using fixed bed, what happens? This is electrical layer is going and we are slowly heating the substance. But microwave is new concept. So if we can reduce the time by putting some energy and can activate it, so it will give us new types of carbon. So our strategy was to get new type of carbon. There is another strategy that we put potassium carbonate, which is carbonic acid salt, right? Usually for activation, people use phosphoric acid, sulfuric acid, or strong base like sodium hydroxide or potassium hydroxide. Purposely, we have taken with carbonic acid salt so that we can actually see that effect. And we wanted to to keep the process as much as possible eco-friendly. And if we use a harsh corrosive acid like others, then there will be apparatus also get destroyed and something like that. So we tried out in this method that okay, we can get on, but ultimately our result is good. We got 1390.76 per gram surface area. So it is good for us.
Okay, thank you, Dr. Zaira. So I think we are going to reach the end of this session.
Doctor,
So
there
before
is a
that,
question in
yeah,
chat.
I am honored to announce the best presenter for this session. Okay, so the IT committee, maybe you can share the slide. All right. So the best presenter for this session, okay, para session number 4, biofuel, biomass, biodiesel. The best presenter is Mrs. Afrin Jahan. So congratulations to Mrs. Afrin Jahan. All right, so now we reach at the end of this session. So thank you for your presentations. On behalf of the MICNC 2021 Organizing Committee, I would like to seek for your kind cooperation to fill up the feedback form as given by the session moderator. So now you are invited to join the rest of the event. So actually now we have an event a talk at the live stage. You can join that, but I would like to actually ask more questions from Dr. Zaira and Dr. Adiola. Can we ask it in this session? Is it possible? Others can move to the live stage, but is it possible for me to do that? Afrin?
Yes, you can stay.
Yeah. Okay. So Dr. Zaira, because I don't want to delay the thing, so because we have another session at the stage, I would like to know for Dr. Adiola and also Dr. Zaira, when we are working on this activated carbon, right? So it is still favorable because of the low cost of this activated carbon, but currently a lot of people working on the new material like graphene, CNT, and so on. So there is one issue that this activated carbon is very difficult to hold the nanocatalyst. I would like to know your experience. Is there any way for us to make sure activated carbon can be, shine again, but with the presence of nanocatalyst? I have tried, but yes, it's easily leach out. I don't know. What is your opinion on this? Your voice is chopping. I don't know why.
If we stop the video, is it okay?
This one better. Yeah, this one better. You have to off your punya video.
Okay,
Yeah.
doctor. Actually, what happened? Activated carbon can act as good catalyst. In that case, we can use another water treatment method. That one we call Fenton process or catalytic weight layer oxidation. In that case, what happened? We will say Fenton process. We have to dock iron over the activated carbon, and catalytic weight layer oxidation process we have to pass oxygen continuously inside the water. So this is another two method for water treatment. But for industrial scale removal of pollutant, when we are dealing with large volume of water, because it is continuous process, that moment the polluted water will come and we have to quickly move to the next cycle of water we have to receive. In that case, until now, adsorption process is dominating using activated carbon. But for membrane process, membrane separation process and desalination, nanocarbon is dominating, because what happens, nanocarbon gives the membrane highest water flux. I mean, more water can flow through the nanocarbon. That is the thing in the membrane, and it can give the strength to the membrane. That is another thing. And membrane has the tendency for membrane separation process, let's say ultrafiltration, nanofiltration, microfiltration, it has the tendency of accumulating biological pollutant. So this is called biofouling. So the membrane will be destroyed and we have to replace it. But if we put some nanocarbon inside the membrane matrix, the membrane will get strength, more water will pass through the CNT tube or graphene hollow sphere, it will pass through. So more water will be there, and we can reduce the biofouling. That's the thing. This is the principle. That's why for membrane separation process, okay, we are with nanocarbon. For catalytic weighted oxidation, photocatalytic degradation also, okay, we can do the nanocarbon, no problem. But again, for photocatalytic degradation and catalytic weighted oxidation, the ultimate water we are taking out, that one we have to analyze GCMS to see maybe the parent pollutant has been degraded to give more pollutant substance. So that is the challenge. But for absorption, whatever be in the solution, more or less it will be absorbed.
True.
That is the thing. That's why absorption process is eco-friendly, but we have to regenerate the absorbent. We have to regenerate the absorbent and reuse it so that the process will be economical. That's the reason.
Thank you, Dr. Zaira. And now, Dr. Adiola, are you there? Dr. Adiola, I am interested with the study that you mentioned you performed the desorption desorption study in order to see whether the substrate, the pollutants attach strongly to the adsorbent. Like so, but usually we would like to recycle or reuse the adsorbent, right? So if it is attached too tight to the adsorbent, what will be the best way to remove it later? Or it just one-time use? What is your opinion and your suggestion on that?
Yeah, thank you, Prof. Yeah, there are two different things. There are two different things. For example, for this case of to know the recontamination tendency of any adsorbent, it's a different experimental approach. What we just do is after the adsorption, then you take that adsorbent with adsorbate, take them to the new environment, the same environment, but without the pollutant. Without the pollutant, only fresh water, for example, in this case, only fresh water in this case. Put it in the fresh water and do the agitation again. I mean, you do the agitation and see, does it release anything or not? If it releases, then that means the amount of what it releases determine how strongly they are attached. This is recontamination. And for regeneration, is very easy. Regeneration that means you have to add some chemicals. If you want to regenerate, you had some chemicals to remove it forcefully. That's another experiment entirely.
So what usually you found for that green adsorbent? Is it easily to regenerate or just one-time use?
Actually, I didn't. At this level, I did not try it. It's part of what we're gonna try later. We did not try it, but in my own opinion, it will not be because it is not a strong. It is not a strong interaction that much. It's not a really strong interaction. It will be very easy for us to regenerate, in my own opinion.
Yeah, because what we realized when we did the systematic literature review, my student did this, we couldn't find many studies that reporting the regenerations of the activated carbon. So we are wondering why there is not so much data on that. Is it because it's very difficult or right? So that is why I'm asking. So
Dr. Rika, sorry.
Yeah.
I'm really sorry for interrupting, but I just want to say that I really enjoyed this conversation. And if you don't mind, can I also be a part of it?
Yeah, can. Sure.
Okay. Thank you. First of all, actually, I have one question just now to Dr. Zaira. Perhaps maybe you overlook it in the chat box. There is one question from me. Actually, I really interested with Dr. Zaira presentation. Oh, by the way, my name is Ruhaida. I'm from University Technology Mara. Okay, I am very interested with Dr. Zaira's work, and I actually would like to ask an opinion in terms of the important surface characteristics that will affect the fates and also the toxicity of the surface engineered carbon. So I really keen to know because I think the studies on the fate and the toxicity of nanoparticles is gaining much interest and is creating more important, especially nowadays. So maybe Dr. Zaira, can you please share with us?
Yeah, thank you for your nice question. Actually, first of all, let's say for carbon nanotube, we see carbon nanotube and graphene, we see the hydrophobicity and hydrophobicity. If it is
Dr. Zaira, the sound, do you, Ms. Ruhaida, do you hear clearly?
Unfortunately,
sorry.
turn off the microphone because there is three-person opening, windows opening. I think the microphone needs to, the other people needs to turn off, then we can hear. Is it okay?
I'm sorry. I'm not so sure
I think it was not clear. But we have to be, you know, really listening to your punya words. Probably, is it possible? Can you use a earphone or? I'm so sorry because it's chopping kan, Dr. Haida.
Yeah, right. I thought that my line is not working very well because now it's heavily raining. But I think it will be not that so clear. I think. Yeah.
Is it
Oh, still the same. Still the same actually.
Oh, that means the network problem.
Is it possible maybe Dr. Haida and Dr. Zaira schedule in the networking? Probably the connection will be better. I'm not so sure. Or just
maybe
yes, sure.
Yeah.
I think we can continue the discussion in other platform through the email or maybe through the chat. I mean like a meeting. So yeah. Thank you very much, Dr. Zaira.
My email is there. Can contact me in the email?
Oh yeah, sure, yeah.
Okay.
And
sorry for
the laptop code, the audio punya system. I think the issue is the audio system of Dr. Zaira punya laptop. Dr. Haida, you would like to ask more questions? Probably to Dr. Adiola?
I actually in regards to the desorption experiment as well because I think I'm also working on the desorption process, the regeneration process of my adsorbent, and I very much also interested with the presentation from Dr. Adiola, and I do agree with him that when we're talking about the desorption, consideration two things. Number one is there is two aspects. If let's say at one point we want to have a strong desorption of the pollutant towards the adsorbent, for example, because if let's say the absorption is very weak, I mean it is easily dissolved, so it also will creating a problem in terms of they can't really attach, the contaminant can't really attach to the adsorbent, so it will be creating a problem as well. But on the if let's say we are looking more towards the regeneration, so of course we are also looking forward to a easier desorption process, so that after the desorption and then the adsorbent can be recovered and it will be able to be reused for another cycle. So I think in my opinion, it is basically looking on what is the main objective of your material, because perhaps maybe for some material that is very cheap, maybe the cost of incineration may not be as high as others, so that one single usage is adequate enough. I mean, without the need of regeneration, because even though on one point regeneration maybe can reduce the amount of environmental waste built up. I mean, but at the same time we need to consider as well the desorption process if let's say we are using chemical eluents. So that is also actually creating another pollution, perhaps especially when we are dealing with for example using acids or EDTA for the desorption process, and also ultimately the cost. I think so. I think there need to be a balance between the cost and also looking into the potential of the secondary pollution. So I think that's my opinion. Even my material as well, we have the difficulty to dissolve as well by because what we aim is that we try to use a mild conditions. I mean, like even though we use concentrated, even though we use, for example, base and acids, but we try to maintain it into a low concentration, like just 0.01 molar, for example. Without using a high concentrated, that will create an issue in terms of neutralization and so on. But for some material, I think the desorption will be quite a problematic. So we need to whether we want to do or not. So I think that's my opinion. Yeah.
Thank you, Dr. Haida. Thank you, everyone. So I think that's the end of this session. Anybody would like to say something? Dr. Aldiola? Dr. Zaira?
Thanks for having me. Thank you very much. I really enjoyed the conversation.
You're most welcome. Mrs. Afrin, you would like to say something?
Thank you very much, Chair.
Okay. So I also have nothing to say. So thank you. So see you again.
See
Thank you. See you. Thank you, Dr. Rika. Thank you, everyone.
Bye.
Dr. Adiola, you want to say something, or we can close the session?
For sure, you can close.
Okay. Thank you very much.
Thank you.